What is version control? Version control is also called source control or revision control. A version control system remembers the history of your files so that if something goes wrong, you can get to an earlier version. A version control system also is going to help you share changes, whether you're working in multiple locations or in a team. You've probably used your own version control system before, like Resume October 2014, where you included a date within a file name. Or maybe you used a version number, like company logo 2 or plan version 5. Of course, file naming is not for everyone. You can use on your own computer a local version control system where you are using currently a file and then you're saving it, adding to the name an extension like version 1, version 2, version 3. And you're doing a save as each time you're saving your project. So that would be your own local version control system. But why would you use anything different? That should be able to work, right? Well, oftentimes you're going to be working on a project that's going to be very large, that's going to change quite often, where multiple authors are going to be included, and therefore a version control system is needed. A version control system is also going to allow you to have the backup and restore to a previous version whenever things go wrong. A version control system is going to allow people to share files and stay also up to date with the latest version of the project. A version control system is going to allow you to undo long-term and short-term as well. And it can also allow you to track changes and ownership. Who done it, for example, will be able to be answered thanks to a version control system. A version control system can allow you to do what's called sandboxing. That means that you can make a temporary change in an isolated area, test it, see if you can work out the kinks, and then check in the changes with the rest of the project when it works to your satisfaction. You can branch a copy of the code as well in a separate area and modify it in isolation. Later on, you can decide to merge the work back into the common area or not. There are basically two types of version control systems that are in popular use: distributed version control systems and centralized version control systems, and we are going to discuss both very quickly. With either type, you always have a working copy. That's basically your project's files on your own hard drive, and a repository, which is basically going to be a record of the entire history of your project. When you're going to make some kind of change in your working copy, then you have to commit your changes to your repository. You can grab an older version from the repository as well if you need to. So, what is a repository? It's a database of all of the changes. The working copy, it's also called the checkout sometimes, is where you actually do your work. It won't affect your teammates when you're working on that copy because it's local on your device. When you're happy with the changes that you have made and you're ready to share them, you're going to commit the changes to the repository. And then your repository may have some changes that were not applied to your copy. Somebody else made some changes and they are not in your current working copy, so you can update it with those changes. So let's take a closer look at the centralized version control. Centralized systems use a central server, which is going to store your file's history and is going to also control access to those files. This is going to be kept separately from your working copy. Your working copy, is the one that's on your device, is going to only store the current versions of the project's files. When you commit those sets of changes that you have made, they go directly to the central repository where collaborators can go and get them. Some of the centralized version control systems that are well known are going to be Subversion, ClearCase, or Perforce. Perforce is probably one of the popular ones. Oftentimes these come at a cost. So we imagine on computer A, there is someone is working on computer A and somebody working on computer B. And they could be in separate locations or in the same building. And the central server is going to keep track of the different versions. So I'm going to go back to the chart in just a second, but in that centralized version control system, each user has its own copy. And then as soon as you commit, your teammates can update the changes. So if you make some changes to your copy, you're going to have to commit your changes to the server, and then they will need to update their project to see what changes you have made. So basically here, if computer A makes some changes, they will commit their changes. They will save in the version database. They will save it there. And then for computer B to be able to see those changes, they will need to update their current project with the changes that were pushed out to the central server. That's just a one-step process or two-step process to go from computer A to computer B. Computer A commits, computer B updates. In a distributed version control system, it's going to be including an additional step. A distributed version control system is a program that stores the entire history of the project files that you have into a hidden folder inside your working copy on your computer. And I will show you when we're going to do a demo here. I will show you how to see that hidden folder there. You can transfer your project history between different copies of the repository, and each copy is going to contain the entire history, and the software keeps the copies in sync. Some of the distributed version control systems include Git and Mercurial, and this list is not exhaustive, of course. So this is kind of how it works here. Computer A has a file they're currently working on, and when they feel like they've made a good set of changes that kind of belong together, they can commit their changes to their local repository where it kind of tracks their local changes into different versions. Once those changes are done and they're happy with everything, they need to push those changes. After committing them, they can push them to the server computer. If computer B wants to be able to see those changes, they will need to pull those changes into their local repository and then update their working copy. So it's a four-step process if we want to have information done on computer A be seen by computer B. We're first going to need to commit to the local repository, then push to the server computer, and then the operator on computer B will need to pull those changes into their own repository and then update their local copy. So each user gets their own repository and their own local working copy. When you commit, nobody has access to those changes except for you yourself. You have to push those changes to the central repository. When you update, those changes are not going to be seen. First, you're going to need to pull them into your repository and then update your project. So the steps for somebody else to see the changes that you have made, you will need to first commit, then push, and the others will need to first pull and then update. Commit and update commands only move the changes between the working copy and the local repository, so that's only done on one computer, and push and pull are managing changes at the server level. So it doesn't really make any changes to your working copy. Sometimes it is convenient, and for a new user is also recommended to perform both the pull and the update, and the commit and the push as well. Conflicts are probably the scariest part of version control. It's basically going to occur when two different users are going to make changes at the same time on the same files. At that point, the version control system cannot decide which one to keep and which one to get rid of, and so you will need to intervene manually. In a distributed version control system, there is an operation called merge that can try to combine edits that are conflicting. Sometimes it can work out successfully, and sometimes the user is still going to need to intervene. In the centralized version control systems, merge can happen implicitly, and the user will be prompted to make any kind of changes and adjustments as needed. So ideally, we want to avoid conflicts. Avoiding conflicts is the easiest way to manage them. So what are some of the best practices to avoid conflicts? The first one is try to use descriptive messages when you are committing your work. That way, people will know exactly what kind of changes you've been making in that portion and will be able to tell in advance whether they have some code that could be conflicting with yours or not. And that way you can discuss and communicate with the other user and make sure that you don't have anything that could conflict. Ideally, when you make those changes, make sure that you are modifying things that are part of a logical unit. You're working on one feature, like implementing the player movement, or you're fixing a bug. Just try to keep that change consistent. Another important way to avoid conflicts is to not assign two people to work on the same thing at the same time. And if that's needed, then in that case, make sure that they collaborate thoroughly so that they don't modify the same file at the same time. Maybe they work at different times. Another aspect that is important is to incorporate other people's changes frequently. So you decide to start working on the project on a particular feature that you are tasked with. The first thing you need to do before you start working is making sure others have not made any changes to the project. If they have, then you should pull their changes to your repository and then update your local copy so that you don't have potential for conflicts. When you are done working on that logical unit, then you should also make sure to share your changes. I've had a situation one time where a student waited till the day before the project was due to submit all of their changes to the repository and to the central server with the teammates. And there were a bountiful amount of conflicts that they had to resolve before submission time. So that was a terrible situation to put everybody in. You do not want to be that team member. Therefore, share your changes frequently. And then communication, just like everything, is important. Make sure to coordinate with your teammates with who is working on what at what time, and communicate. If you have maybe a Discord channel, just communicate with your teammates saying, I'm planning on posting my character with the animations there. Is anybody else working on this file, that file, before you make any changes? And there's a way also, depending on the version control system that you're using, there's a way to set up email notifications. So feel free to do that as well so that you know who is working on what. Now, for the second portion of this video, I'm going to do a demo on how to set up a Unity project using Git. Git is a distributed version control system, and to be able to interface with it, I'm going to use GitHub Desktop. You can go to desktop.github.com to download the application there. I've already downloaded it, but the installation is quite simple. Once you have downloaded it, you can open up the application. The first thing that you will need to do is make sure to sign in. So you can go under File, Options, and Sign In. If you do not have an account, you will need to create one. So you can click on Continue with Browser, it will open up the browser here. And when you get to that part, you can create an account if you don't have an account. You can use your school email or you can use your own personal email. It really is up to you, depending if you want to have access to this information after you graduate from the college. So I'm going to sign in using the browser. It will ask me for authentication, so I will pause the video and handle that. Once I've handled this, I can say open GitHub desktop. And I'm logged in. I can go ahead and check that I'm logged in, going under File, Options, and then you can see I am signed in github.com here. The next step is going to be to create a new repository. So I can go under File, New Repository. I can give my repository a name, hopefully something meaningful for the project. In my case, I'm going to just call it Video Demo 2023. You can provide a short description for your project. That can be modified later on, but you can provide a short description here. I'm going to say this is just a demo for version control demo. You can choose the local path. Where do you want to save that repository? And again, those files are going to be hidden there. It's going to be where you're going to have your project. I'm going to place mine on the desktop so that'll make it easy for me to find it when I'm trying to show you where it was created and what it contains. You could select to have a README file or not. It's up to you. The next part that's really important is the git ignore. There are many files in Unity that you personally do not modify, like the library folder. And a lot of these don't need to be tracked because Unity can recreate them when you open the project. And so we're not going to track the changes for those files because they can be done while opening the Unity project. And the git ignore file is basically going to dictate which files should be ignored. You can see there's several programs here that have pre-written git ignore files. And if I scroll down, I can find Unity. There's a Unreal Engine. There's Visual Studio. You can take a look at that if you're curious and you have time. So I'm going to use git ignore Unity. But for the license, I don't need to enter anything. And then I'm going to click on Create Repository. This may take a moment. When it's created, I can go ahead and navigate to my desktop. And it might be on the other one, on the other monitor. And you can see there it is. So I can double click on it and it shows me this folder here. Chances are that Git folder will not necessarily be visible on your device because this is by default hidden. And you can choose to show it or not. You can go under View and choose to show or hide specific items. So this by default here is hidden. And if I click on it, there is my repository there. You can see the git ignore file that can be opened up using Notepad. And I like to specify that open with Notepad. And you can see some of the folders that are ignored, the library folder, the temp folder, etc., etc. And you can kind of look at C# project that Visual Studio Create is going to be ignored. User preferences is going to be ignored. You can take a look at some of the things that are going to be ignored there. That's basically your local repository created. Now that the repository has been created, it is time to create a Unity project. I will see you when my project is ready. So my Unity project is ready to go. There's really not much in it right now. It's just a simple project. And I created it on the desktop. So you can see the folder right here. This is the Unity project. So what I want to do now is move the repository that I have created, which is right here. I want to move these files inside of my Unity project. If you remember, the repository that's local is the one that's going to keep track of your changes throughout the development process. And so it needs to be a part of your project. So I'm going to select the files that have been created for the repository. I'm going to click on Control X to remove them. And I'm going to place them in the same folder as the root folder of my project, right here where I see assets. So I'm going to right click here and paste my Git information there. So again, make sure that you copy the hidden Git folder, the Git attributes, and the Git ignore file in the same folder as your assets folder for your project. Once that's done, you can close the file explorer there. You can open up your Unity project, no issues. I'm going to open up GitHub Desktop, and it's telling me, I don't know where your project is gone. You've moved it. That's because if you're looking in the desktop here where I had the video demo, that's my repository. If I click on it, the folder is empty because I moved all of those files into my Unity project. So I'm going to click on Locate, and I'm going to identify there where my Unity project, and I can see here already the Git folder. So I'm going to select this folder, which is the root folder of my Unity project. And now you can see it's providing a list of changes. Right now it's only providing 28 changes. If you think about it, that's an entire new Unity project. It's not bad. So the changes that you make inside of your project will be listed there. And if you get something around 30 changed items for a new Unity project, it's fairly reasonable. It means your ignore is set up the way it needs to be. If not, revisit the beginning of the video here, the beginning of the demo, to see where exactly I copied the repository. So I'm going to make my first commit. The first thing I need to do is at the bottom here of all of these changes, and I can select them individually to see. Green means these are things that I've added, and then red would be something that I've removed. So here in the summary, I'm going to write initial commit. I can specify in the description and provide additional information. Empty Unity project, for example, would be a good one since I'm just getting started. And then I can click on commit to main. So basically what this has done is it saved the changes of my Unity project in my local repository, which is great, but I'm nowhere near done. Now what I need to do is publish that repository to the server. Locally, I'm good to go. I've made my commit. That means all the changes in my Unity projects have been saved into my local repository. Now I need to push those changes, and actually because it's the first time it's going to be to publish those changes into GitHub. And you can just use this button here, publish the repository. On github.com, it's going to ask what's the name. I'm going to keep this name here. You can see I could change the name and the description if I wanted to. You can choose to keep this code private or not. I'm going to keep it private because it's just for me. But if you wanted to be able to show it to other people, not necessarily your collaborators, but maybe potential employers, in that case, you would want to make it public. And then you can choose, if you had an organization with your account, you could choose to set up an organization there or not. I'm going to choose none. I'm going to click on Publish Repository. It will take a moment. And in that case, I'm pretty much ready to go. Now let's see what has happened on github.com. So to do that, it's very simple. I can open the repository page on GitHub in the browser. So I can click on this button here. And there is the page. You can see the initial commit there, when it happened. You can even see when was the git ignore, git attribute, and the config set up, which was like an hour ago for some of these files. You can look in the assets. You can see the scenes. There is the sample scene, so you can see the information about the project there. So my project is ready to go. I'm going to go ahead and add a change to my project. So I'm going to include a cube in my project, and I'm going to rename it enemy. because why not? And let's say I'm going to move it there. This is the changes that I need to do for my enemies. I'm going to save the scene. I can save the project as well, although I haven't made any changes there. Now I can go in my GitHub desktop, and you can see that I've made some changes in my settings, 3 of them. I can see a little bit of the information that have been modified and changed. You can kind of dive into that if you're interested in trying to decrypt what's been going on. But you can see those are local changes that I need to commit. So in this section here, I can provide a summary. The summary is required. The description is optional, but I would highly encourage you to provide both. Summary, added enemies to sample scene. By the way, that's a terrible name for a scene. And then here you can add additional information. Added an enemy in the scene and set it up in its initial position. Just some details. Of course, I didn't do anything significant there. Once I'm done, I commit to main. That means the information that I have, the changes that I've made in my project have been saved to my local repository. But you can see right now there's no local changes. However, if I look here, it tells me I need to push. You have one local commit waiting to be pushed on GitHub. Now, if I were to push to the origin, it will basically push my changes to GitHub, basically, so that the centralized server, so that other can go ahead and pull those changes and update their local copy. So we kind of worked on setting up the project and making changes to the project and pushing those changes by first committing to the repository, then pushing to the server. So I can go ahead and take a look at the browser with the GitHub information there. I can refresh that page. You can see now in the assets and the project settings, this has been because I saved the project. It shows that added enemies to the sample scene there. So I can see what has happened there, and that's on github.com. So our goal now is going to be to invite collaborators, people that we will want to work on the project with. So the way we start here is to go under the settings. And if you are looking, there is a section there that's called collaborators. So this is the part where you can invite other people to collaborate with your project. When you click on add people, you can look for them by username, using their full name, or using their email address. So make sure you get that information from your collaborators. So I'm going to add a collaborator here. There it goes. That's another account I've created. I'm going to add that collaborator to my project, and my collaborator has been invited. Now I'm going to sign out and log back in as that collaborator so that I can show you what happens on the other side and how do I create a local copy there. So I'm logged in as the collaborator now, and if I check at my notifications there, I do have the invitation to join here. And of course, I just need to accept the invitation. And by the way, I get access to the GitHub demo project that I created from that other account. And so what I need to do at this time is create or clone the project so that I have a copy and a local repository on my device. So my issue here is when I try to clone the repository is that it's trying to access the same folder as the one that was used by the other collaborators. So I have to choose a different section to do that. I'm going to place it on my D drive for now, and I'm going to put it on my work folder. I'm going to select this folder there. That's going to be my local information. This is the repository I want to clone, and I can click on clone. There it goes. So now let's go ahead and try to open up that project in Unity. I'm going to go here where you can see I have the other one there. I'm going to open that repository. If you remember, I placed it under my D drive, under my work folder. And there is my GitHub demo project. I can open it up there. It'll take a moment. So the Unity project opened up. Now, in my situation there, I'm working on the same computer, which makes things a little bit funkier to set up. So you would not get the error I received that the folder already had files, because I can't have the two repositories on the same folder. But once I selected a separate location, it created a repository. Now you can look, if I do my Explorer here, I look at the desktop, I do have the GitHub demo project there. That's for collaborator A. And then if I look under my work folder under the D drive, which is a little bit messy, but I will find also my GitHub demo project that was manipulated by collaborator B. And so collaborator B could go ahead and add maybe a sphere and call it a player. Now, I'm going to mention a few things about this. I could go ahead and save my scene. Now, if I go back to the desktop, I can see that I have some changes that have been implemented there in the scene. I could do a commit and say added or player movement. I didn't really do any movement, but we're going to assume I did. Added a player object to sample scene with the movement implemented. Commit to main. This is going to be tracked in my local repository, and then I can push to the origin so that the other collaborator can see those changes. Now, I'm not going to switch back and forth between two operators there, but if collaborator A wanted to see those changes, they would need to first pull the changes to their repository and then update their copy. So that's basically how you kind of work these out. A big note of warning there that I need to mention when it comes to better practices is my two collaborators worked on the same scene. Not at the same time, luckily, but on the same scene, which could be dangerous. So let's go back over one more time over best practices. So for version control, best practices. Make sure that you specify a commit message that is descriptive. Add description with it to be more specific. When you're making changes, put changes that kind of belong together. Don't try to do 20 different tasks within one commit. I'm working on the player movement. This is going to be my commit. I'm going to fix a bug. That's going to be another commit. Don't assign two people to work on the same code at the same time. This includes the same scene, or even worse, the same prefab. So be very careful with that. Make sure that you are doing work after incorporating other people's changes. So make sure you pull and then update before you work. And when you're done working, share your changes by committing and then pushing. Communication is key to avoid issues. The more you coordinate with your teammate who's working on what and when, the fewer conflicts you will have to handle. And you can set up email notification, or you can have a Discord channel to kind of discuss those changes. There you have it. I hope you have a better understanding of version control. Thank you for watching.